Hey there! Welcome to NASA Connect, the show that connects you to the world of math, science, technology, and NASA. I'm Van Hughes.
And I'm Jennifer Pulley. Today, we're at Disney MGM Studios in Orlando, Florida. We are your hosts, along with Norbert. Every time Norbert appears, have your cue cards from the lesson guide and your brain ready to answer the questions he gives you. And teachers, every time Norbert appears with a remote, that's your cue to pause the videotape and discuss the cue card questions he gives you.
Fasten your seatbelt.
On today's show, we'll learn how NASA researchers collect and measure data, recognize patterns, develop functions, and use algebra to solve their problems.
Then they compare the results and predict how the technology will perform in space. Plus, you will simulate NASA research and learn all about magnetic forces and how they cause motion.
And you know what? You're going to be doing all of this in your classroom.
It's going to be a thrilling ride.
Later, Dr. Shelley Canwright will get you hooked up to this show's web activity. Today's NASA Connect program features patterns, functions, and algebra to get you wired for space.
Did you know that NASA researchers use math, science, and technology every day to make sure space transportation is safe and reliable?
That's right, and more affordable too.
You know, NASA Connect has sent us on some pretty cool locations, but Disney MGM's rock and roller coaster starring Aerosmith is definitely a gas.
Gas? Not gas, Van. This coaster uses state-of-the-art electromagnetic motors.
Electromagnetic? You mean this roller coaster runs on electricity and magnetism?
Exactly. Electricity is one of the fundamental forces of nature that we use to make things work for us. Magnetism is the force of attracting or repelling magnetic materials. Magnets have the power to pull things toward them, but they can also push or repel things away. When you connect the power of electricity with the strength of magnetism, you can make an electromagnetic motor, like the one that gets your clothes clean in the washer. Today, we're learning how electricity and magnetism are used for what you might call another type of spin cycle, propelling spacecraft into orbit. 0 to 60.
Oh man,
2.8 seconds.
That was so awesome. Now tell me, how does a roller coaster like this relate to NASA and spacecraft? Not that I'm complaining, but I want to ride it again.
Well, okay, we will. Hang on, let me tell you. NASA is working on a way to propel spacecraft into orbit. And get this, they're using a track very similar to this roller coaster track. All right. Hey, let's propel ourselves over to NASA Marshall Space Flight Center in Huntsville, Alabama, and check it out.
Jennifer, this is supposed to be like a roller coaster? Where are the loops?
Well, it's not like a roller coaster in that way, Van, but it does use some of the same scientific principles. This is Jose Perez. He's the Launch Assist Project Manager from Kennedy Space Center in Cape Canaveral, Florida.
Thanks, Jennifer. Getting into space is expensive, and the first part of the trip costs the most. That's where this track comes in. It is used for magnetically propelling a spacecraft. Like magnets, electricity has a similar push and pull called charges. In fact, electricity and magnetism are a lot alike because they are really the same force of nature. We're just used to thinking of them as two different things. That's where maglev, or magnetic levitation, comes in.
Okay, so what is magnetic levitation?
Magnetic levitation, or maglev, is a new technology being developed for high-speed trains. Instead of running on metal wheels, these new trains float or levitate above the track.
Levitate?
Yeah, how does that happen?
Well, electromagnets in the track levitate and propel the vehicle down the track without any direct contact.
Cool, I get it. Electrical charges are like magnetic poles that repel each other and pushes it down the track.
Exactly. The magnetically levitated spacecraft will leave the track traveling around 600 miles per hour and then reach orbit using rocket power.
What kind of tests did they use?
Were there any patterns in the results?
What kind of graph resulted from the data?
One of the things that we test is how much force is being produced by our electromagnets. To find the force, we use this equation. F equals m times a, where F is the force, m is the mass, and a is the acceleration. Acceleration is the increase of speed over time. We put sensors aboard our test vehicle that measure its acceleration. Since we already know the mass of our test vehicle, if we multiply the acceleration by the mass, we can determine the force. Taking those numbers and producing line graphs, we can show the forces on our test vehicle. The pattern that develops helps us predict the performance for future space vehicles.
Wow, that's a pretty exciting way to understand math. You use math every day, right?
Yes, and we also share our results with people in industry and other NASA centers. By looking at our results, they can understand how much the carrier is accelerating and how much force the track magnets are generating. Because we speak the common language of mathematics, we can share what we learn, and we learn from each other.